would like to move for our next speaker. So our next speaker is Dr. Charito Medina, and his expertise in organic agriculture and sustainable food systems, agroecology, conservation and restoration, ecology, species interactions and dynamics, climate change, resilience, natural resources, and so on. And Dr. Medina is a founding member of MASIPAG, and he served as a member of its board of trustees for a long time, like 11 years, and also has vast experience to work in this field. And in the academy, he is an associate professional lecturer in the environmental science and education at Manila. I was also served as an associate professor of environmental science at the University of Philippines and Open University. So, so is a great speaker. Yesterday, I have gone through his lecture. His strong and dominant delivery he has, and Dr. Charito Medina will talk on principles of community participation and leadership. So now I would like to invite Professor Medina to deliver his lecture. Dr. Medina, please.
Thank you, Dr. Ganguly. I hope you see my screen now. Can anyone?
Yes, it's coming, but we cannot see properly the screen. Is it large, very large?
What's that?
See.
Can you see my slides?
We can't see. Yeah, your screen is not properly visible.
Okay.
The
sound is so not so very clear. So is it okay for me to proceed now?
Sir, it has some problem. It is seen vertically. I think your file has some problem.
My file is not visible to you.
It is okay now.
Okay now.
Yes, yes.
So I can now proceed. I can proceed now.
Yes, sir.
Yes, yes.
Okay, thank you very much, Dr. Sumon Ganguly. As he has introduced, I'm from, I have worked for a long time in a NGO called MASIPAG, but the English name actually of that is Farmer Scientist Partnership for Development, with working for 33 years, 18 years doing participatory development, and 15 years working on farmers empowerment and people farmer-led development. In my presentation is called community leadership. So let me proceed. The objectives of this session is in general to describe and understand the rural development approaches, and in particular to describe three approaches that are emerging. The first one is the oldest model, the transfer of technology model, to describe and the use and limits of transfer of technology, but in very brief discussion, to discuss participatory research and participatory approach to development, and to explain the emerging approach of PLD, or people-led development, or farmer-led development to some. This is my supposedly the outline, but the outline is already the contents of introduction. That the common thing that I think everyone is aware is the transfer of technology. It's the oldest one, and still many are still using it. It is coming from a reductionist framework, and the scientists do the research, extension work, do the transfer of the knowledge. Farmers are passive recipient of technology. So in that case, the research are in controlled environment, the technology generated are in controlled environment, and the transfer of the knowledge is linear. In the second method, the so-called participatory research or participatory development, sometimes at a later date it's called knowledge co-production or co-learning between farmers and scientists, or between farmers and development worker. And then the most recent is the farmer-led development or people-led development, which is about working on integrative thing, as farming is actually really integrative. In this participatory or farmer-led, there is no hierarchy of knowledge forms. The farmer's knowledge or scientific knowledge by the scientists, but it is with action. It is democratized technology that is participation of the farmers. The knowledge exchange is two-way between farmer to scientist and scientist to farmer. So it is diffusion, not transfer. It is iterative and systems network. I will elaborate on this anyway as we move along. But before I proceed, let me mention that the so-called framing of technology and rural development is that there are two framing or the way people look at it. The so-called information deficit model, there is a lack of information. Therefore, the assumption is there is lack of public understanding, and the solution is to transfer and give more technology to the farmers, and the farmers just receive it. The other framing is that democracy deficit model, meaning there is lack of public participation or farmers participation, and the solution here rests or has a foundation on more participation. The first approach and I think the approach that you all know is the transfer of technology model. In the discussions of yesterday and in the previous presenter, there are describing many approaches, and these are actually developed mostly, of course, they have documented the local farmers in some instances. The scientist is the source of knowledge. It is generalized technology, and extension services transfer that knowledge or technology, and the farmers are only adapters or rejectors of technology. The key research decisions are made by scientists, and this has been found to be very successful in uniform and controlled farm conditions. If the farm condition is not uniform, it is uniformitized by the use of chemical fertilizers and pesticides, so that it can eliminate the challenges to food production. But we need an alternative approach in this case, because this transfer of technology is a kind of top-down approach, and it has missed many resource-poor farmers. In fact, it has alienated them. The package of technology in the transfer don't fit variable agro ecosystems, and there is big gap between potential yield versus actual yield. Most research actually are focusing on yield under ideal condition of fertilizers and no pest at all. And in the farmer's field, the challenges for soil fertility, pests and diseases are always there most often. And therefore, with this kind of challenges, we need integrative approaches. So, in fact, the most pioneer about participatory approaches, Robert Chambers, in 1993, he said, professionals, you and me, are much of the problem and then the solution. To do better, we need the reversals in much of our conventional ways of thinking, doing, and feeling under the transfer of technology model of research and extension. He said further, Robert Chambers further said, perhaps it is time to move back and give way so farmers can occupy the driver's seat, meaning they can identify the priorities, the directions, and how to do things. As I proceed, let me give you first a platform or context of my succeeding slides, the perspective that technology is contextualized. It is relativist in terms of its application or usefulness or utility. Technology occurs in a social, political, and cultural as well as economic context, and it is never neutral. So that if you transfer technology under different context, then chances are it may not fit specific conditions. Technology is always shaped by their use by the people or institutions which control their production and distribution, and by culture which validates, delineates, or discourages their creation and or use. The second approach, alternative to the transfer of technology, is the second approach. It's called participatory approach. So participatory research and development, and as I said a while ago, it is also known on a later date with some improvement as knowledge co-production between farmer and scientists or development workers, or co-learning between development worker and the farmers. So that in this context, the framing or the situation, the way we look at it, we contextualize that farmers are not passive recipient, but active participant in the technology development, as well as in the choice of technology, as well as in the application. No hierarchy of knowledge forms, meaning the scientist's knowledge does not necessarily always be superior than the knowledge of the farmers when it comes to application at specific conditions. The knowledge of the scientists also always are generalized. The knowledge of the farmers are specific to local conditions. And so that is where the difference is. Participatory action research is with action, as it says, participatory, so it is democratized, two-way knowledge exchange, and it is iterative in not only one way, but it can be a cycle, questions, answer, another question, another problem, goes back and discussions and addressing the problem. So it is iterative, cyclic. As I proceed, let me mention then that there are types of participation. The lowest level of participation of the farmers to that of the development worker is that contractual participation. The farmers are contracted to test a certain new variety. Consultative is a higher level. Collaborative, but collegial is more or less co-equal between the development, the technology developer and the farmers. The question here is, the farmers participate in science research or scientists participate in locally owned innovation system, meaning who controls the priority, who controls the direction of research, and who controls the type of technology that has to be developed. Also, the objectives of in participation that we usually don't talk about, but they're so important, they're back in the minds of everyone, but they don't address it. The lowest level of participation is to legitimize the research. So you want to involve the farmer so that you can say they are involved. The effectiveness and efficiency of a technology as a participation of the farmers, capacity building and learning of the farmers so that they learn how to do things. And the highest level of participation is emancipation or transformation of the farmers to be able to develop their own technology and move from the hunger and poverty into sustainable farming systems with their own solutions developed in the farm, especially. And even the scientists still be there, but the role of the scientists may be supportive already at the higher level. In fact, it can be seen in this process when we ask the question, who is participating in host process in the interaction between the farmer and the scientist? We question you, or we ask, host knowledge counts. Do we acknowledge, do we respect the knowledge of the farmers? Or do we simply treat the farmers as knowing nothing? Host priorities and preferences counts. Is it the farmer or the scientist? So as you see in the diagram here, simplified diagram, the role of scientists, if there is bigger role of the scientist and development worker, the role of the farmer is very small, maybe passive recipient of technology. But when the role of the farmer is wider, the role of the scientist may be only supportive and giving some scientific explanation to phenomena that are occurring in the farmer's field under their own experiences. farmers to be involved at all levels of technology development in participatory process, in the diagnosis of the problem, in the experimentation, and dissemination of the technology being developed. There are some approaches to co-learning with farmers. I think this one many of you are familiar already, but have never perhaps ranked onto the broadening of the objective of this so-called approaches of learning process. First is the lowest level is the on-farm research, and then farmer field school, then participatory action research going up the level here, then community-based resource management. I think you are still aware of this, but I think not so much. But this is the cornerstone in my organization in MASIPAG, farmer scientist partnership. So you have to institutionalize the relationship. It's not only a scientist visiting the farmers whenever they want or whenever they like or whenever they funding. There must be more institutionalized relationship between the farmers and the scientists. But now the highest level we've been doing this is called farmer-led development or people-led development. It's of lighter color here because not so many people are doing it at the moment. There are variations and in context as well as content of these approaches, as well as the mechanisms and processes vary from its practitioners. Then that brings me to the second perspective to contextualize my succeeding slides. That is a perspective that there is the so-called modes of knowledge production. Because sometimes people, when say it's a knowledge of the farmers, oh, it's not science, don't believe them. So to address that kind of distrust to the farmers, Gibbons et al. In 1994 made a classification in order to give a framework of how we look at this, and he classified two modes of knowledge production. Mode one is the so-called university or investigator-initiated and discipline-based. It is hierarchical way of research and linear from the researcher or scientist to the user as farmers. So the objective, actually dominant objective here is more of cognitive or knowing what is happening, knowing what kind of technology. According to Gibbons, there is a mode 2 knowledge production, and this is experience-based knowledge. It is context-driven, it is complex, multidisciplinary, and it is problem-solving. One of the speakers yesterday that I was able to listen was saying that local knowledge has to be recognized through policy and recognized through science, put them side by side, because local knowledge is also important and valid in their own circumstances. So that in this mode 1 and mode 2 knowledge production, at least we don't put down immediately the knowledge of the farmer as secondary in terms of quality. We can put them as, oh, that's mode 1 scientist, mode 2 farmers knowledge, because they are produced in the context of applications and verified by its social worth and applicability for the mode 2 knowledge production generated by mostly by farmers as a hands-on knowledge in specific context. Let me give you a little comparison. I don't want to expand much on this, but the mode 1 formal science, mode 2 science, but maybe some of you might be disagree that it is mode 2 is science. Okay, mode 2 knowledge, mode 1 knowledge here. The objective here is oriented towards application in the mode 2 science, farmers knowledge. It is usually transdisciplinary. It's not discipline oriented as in the specified or expert or expert scientist. The application is heterogeneous. The homogeneous is under specific fertilizer application, specific application of pesticides, things like that, or performance of the specific variety. The quality management is of broader criteria, while the Mode 1, scientist knowledge, academic quality control. The accountability of the scientists and the academics to the peers, the accountability of the mode 2 science of the farmers is accountable to society. Does it deliver the desired performance of their own traditional varieties or their own combination of plants and animals? So they are accountable also, but it is to society, whether it contributes positively to social objectives, particularly and most specifically contribution to yield and economic development of the community. So in the second name of that participatory thing is co-learning. Co-learning, as I said, between scientists and the farmers. And farmers are human resources. The framing here is that farmers are human resources to be active participants, not passive recipients of technology. So they are active participants in the development process. They need to incorporate local indigenous knowledge systems. I think I have mentioned that. And to have co-learning, it enhances the relevance of the knowledge being generated, cultural, that is cultural acceptability, and socioeconomic context is being addressed so that the usefulness of any technology generated under co-learning has more or wider use as such in the community. The elements of co-knowledge co-production is location specific. So I said it is contextualized, not the generalized technology from the academy. It responds to farmers' demand rather than imposing standard solution to problems in farming. Farmers and local communities must be involved in identification of research problem, options, and priorities. I think I have mentioned that, but I wanted to emphasize or highlight it further and as a characteristic of co-production of knowledge. Scientific research should incorporate local practices and indigenous traditional knowledge. Some considerations in the knowledge co-production is that it's not a specialist thing, it is a systems or holistic perspective. Because farming, you can not only talk about the soil, you can not only talk specifically and isolatedly about the pest or the disease, or you cannot only talk about the fertilizer or the water. It should be a holistic perspective. In order to benefit the farmer has to integrate all of this natural resource, socioeconomic resources, cultural issues as priorities, and things like that. You have to think in terms of ecological services, broader perspective. The multifunctionality of agriculture is more appreciated here and incorporated, and also looking at externalities, meaning if, for example, some externalities that a seed yields higher, but the externality is that they don't own the seed, they have to buy every time they plant, it's more expensive, and they don't have money. So that can give a contribution into the utilization or non-utilization, acceptance or non-acceptance of particular variety as a form of technology. So these are externalities are too important also to consider, and in co-production of knowledge, these are incorporated into the framing of the research and development. And we focus on locally available resources. Very briefly, let me mention about formal and local knowledge that the formal sector generalized technology over large space and neutralize environmental variations by energy and chemical inputs. I think I have mentioned this actually, by the way. Local knowledge systems by the farmers is developed adaptations to variations in environment with relatively small applications or habitats, and therefore specific to locations, but they work also. That's the important thing. Now, the third approach, that is the topic is community leadership also. We call it in literature and in practice. As I said a while ago, my organization has been doing this for 15 years somehow, evolving from a participatory development before, and now it's farmer-led development, even research. Our farmers breed rice and corn and chicken. We have more than 60 farmers who are breeding rice. In fact, our organization have more than 2,000 varieties of rice. The development is more than 500 developed by the farmers. Farmers define the kind of agriculture and production system that they want in people-led or farmer-led development. Research done in the field is addressing the priority issues of the farmers. The farmers and scientists are co-equal. They're the same in the co-knowledge generation. Again, as I said earlier, there's no hierarchy. And the farmer-led development is anchored on building self-confidence and empowerment of the farmers. As I said, if there are 1 million farmers, if you can only train farmers to be self-confident and learn how to observe and make generalizations, very rudiments of science, although it may not be science as we define it in the academy, at least it is a foundation of generating knowledge and technology for addressing problems with the farmers. And so empowerment and self-confidence of the farmers is very important to be built up in the so-called people-led or farmer-led development. Works best in farmers if farmers are organized. So we need organizations because these are the so-called engine of diffusion of development and knowledge within and between members of the community. So we always, the members of our network in MASIPAG are all organizations of farmers. Of course, scientists and NGOs are also there. A third, perhaps also a context or a perspective, the so-called, I wanted to mention the so-called Postnormal Science. It's developed by Puntowicz and Rabbits. It's published in 2003. The first one was published in 2003. Because we are too preoccupied with doing our specific specialized science, but there are limitations also. As mentioned by Puntowicz and Rabbits, Rabbits and Puntowicz are so preoccupied with the science, philosophy of science also. They were saying that normal science manages complex social and biophysical systems as if they were simple scientific exercises that results to our present mixture of intellectual triumph, but also some socio-ecological peril. Post-normal science is a new conception of the management of complex science-related issues. It focuses on aspects of problem solving that tends to be neglected in traditional scientific practice. PNS considers uncertainty, value loading, and plurality of legitimate perspectives as integral to science in application as it is applied to agricultural production systems, because we are dealing with farmers in this case. So now in the interactions of scientists and development workers to that of the farmers, there should be roles of these scientists and development workers. One, they should recognize farmers as innovators. As I said again, I think twice already, that farmers are not only mere recipients or users of technology, they should be treated as innovators of technology. Respect and protect farmers' choices. Support local developed adapted technologies. Capacitation of farmers to innovate and farm, to respond to the challenges in their specific farm and climate change, food production, nutritional challenges, and many more. It should, the scientists and development workers should enable farmers to develop their own tools adapted to local conditions and needs. In addition to that, some other situations of the scientists and development workers is that we should be able to unlearn our thinking that only scientists know the truth and that farmers are ignorant and they don't know what is technology, modern technology. We have to unlearn that and relearn that farmers' needs, problems, and contexts are also legitimate and farmers are capable of doing it. If you give them support, they will be very productive also along that line. Where I'm not saying that they can be thinking in the same level as the scientists are thinking, but the point is the farmers can generate technology useful in their own context. The role of the scientists and development workers is that also to design appropriate strategies and interventions together with the farmers to provide options and not recommendations, because there is a tendency for us scientists that when we encounter farmers, we tend to recommend solutions. So the other approach when we talk about people-led development or community leadership is that we provide options and the farmers decide what they wanted to pick up and they reject others. Scientists should guide the implementation of farmers' projects and evaluate with them comments on farmers' innovations to provide explanations, scientific explanations of phenomena being observed and experienced. So in this case, they also enhance confidence, self-esteem, capacity of farmers. To summarize that thing in a more simplistic way, the transfer of technology is similar to that compatible of that mode one knowledge generation and the reductionist control environment. The objective is knowing or cognitive, and it's the normal science that we know. And it is, as I said, apps, it is technology transfer. The participatory research and co-knowledge generation, as well as the farmer-led development or so-called community leadership in the context of this summer course, it's mode to knowledge generation. It is democratized. It is holistic systems. It is on real life situations on site, and the objective is problem solving, not only knowing. And this is comparable to that of the post-normal science, and the spread of technology is technology diffusion. Finally, I would like to mention this quotation came from Barefoot Guide to Organizations. If you give me a fish, says the farmer, you have fed me for a day. If you teach me to fish, then you have fed me until the river is contaminated or the shoreline is ceased for development. But if you teach me to organize according to the farmer, then whatever the challenges, I can join together with my peers and we will fashion our own solution. And therefore that highlights or underscore the capability, the potential also of farmers and aided by organizations to enhance self-confidence. They can help one another, they can generate more technology for themselves, by themselves, and among themselves. Thank you very much. These are some references that you might read further if you want to dig deeper, because my presentation actually is more of the categories and the methods of doing it. You can still learn more by reading some of these references. Thank you very much. Thank you, Dr. Somon. Thank you.
Thank you, sir. Thank you, sir. Thank you to finish it in time. Absolutely. So from Professor's lectures, it is very interesting talk, and how dedicated researcher he is, that he pointed out correctly. He pointed out professionalism. That was very nice. I took it much of the problem than the solution in the first section of his talk. And of course, so we need to meet and implement and to share our knowledge and to produce knowledge, and definitely that will turn into lead the co-learning process or participatory learning process. Well, we are running over time, so I would